back everybody, I am our teacher from Ilm Online Academy. In today's video, the topic is the periodic table. This is basically chapter number 13 of the ongoing series for the Cambridge Chemistry 0620, and in today's video we'll be having a look at this chapter, which is the periodic table. Without further ado, let's just begin. And first of all, I will share with you the contents which we will discuss in today's lecture will be: the first one is classifying the elements in the periodic table. The second, we have the trends in a group, and the third is trends across the periods. So we will start with this to learn how the elements are organized into a table of periods and groups based upon the order of their number. Second, this we will describe the relationship between the group number and the ionic charge. Third, we will explain the similarities in the chemical properties of the elements in a group. Third, we will describe the trends in the properties of group 1 elements, group 7 elements, and also in the group 8 elements. Or in the last, we will describe the change from the metallic to the non-metallic character across a period, and also the characteristics of the transition elements. So let's first start with this. The first content which we are doing today is classifying the elements. So we will classify the elements in the periodic table, and periodic table is a table of elements that are arranged in the order of increasing proton number or the atomic number. So periodic table, if we talk about first the periodic table, I will also show you the periodic table which we will discuss today. So there are elements that are present in the periodic table. This is a table of the elements that are arranged in increasing order of their atomic number or the proton number. We have discussed these two terms, atomic number and the atomic masses, in chapter number 2 you can check the video of chapter number 2. And next we have groups and the periods that are present in our periodic table. So elements are arranged according to their increasing atomic number in the periodic table, and we have groups and periods that are present in the periodic table. Groups are the vertical columns of the periodic table that contain the elements in their increasing or you can say that with the similar chemical properties. So these are the vertical columns of the periodic table. And we have elements in the groups that have similar chemical properties because in the groups elements have same number of outer electrons that are present in the valence shells, and chemical properties depend upon the electrons which make the bond with the other atoms. So that's why they have similar chemical properties. And periods are the horizontal rows that are present in a periodic table. So this is about the periodic table. We have elements, we have groups, we have periods in our periodic table, and all the modern versions of the periodic table are based upon the table that are proposed by the Mendeleev. So Mendeleev arranged the elements in the periodic table, and in the periodic table we have the elements that are arranged in order of increasing atomic number. Second, vertical columns of the elements with similar chemical properties, those are the groups, and horizontal rows are known as the periods. So now I will share with you the periodic table. So this one is the periodic table. You can see here we have elements that are arranged in the periodic table according to an increasing atomic number or the proton number. For example, the first element in our periodic table is hydrogen, and hydrogen has just one electron in the valence shell, or in the, you can say, the first shell. So it is present at the first And the second element of our periodic table is helium, and helium has 2 electrons. Third, we have lithium, next beryllium, boron, carbon, nitrogen, oxygen. So all the elements that are present in the periodic table, they are arranged according to their increasing proton number, or you can say the atomic number. You can see here we have vertical columns. These are the vertical columns, and these are known as the groups of our periodic table. So the main groups that are present in our periodic table, there are total 8 main groups of our periodic table, which are known as the main groups. I'm excluding the elements that are present in the center. These are known as the transition metals, and transition metals are excluded from the main groups. So we have total 8 main groups in our periodic table. These are the vertical columns of our periodic table. Next we have periods. You can see here total 7 periods are there, and they are the horizontal rows that are present in our periodic table. So horizontal rows are known as the periodic table periods in our periodic table. So total we have 7 periods in our periodic table. Elements in the groups 1 to group 8 are sometimes known as the main group elements. As I already told you about that, we have the main group elements except the center one. In the center we have the transition metals. We will also discuss the properties of the transition metals in the last. So the group 1 elements, there is a specific name for the group 1 elements, which are known as alkali metals. Group 1 elements are known as alkali metals, and group 2 are known as alkaline earth metals. These are the reactive metals of our periodic table, and the elements that are present on the on this side, like you can say in the group number 1 and also in the group number 2, these are the metals. These are the reactive metals of our periodic table, and the most reactive one among all is the francium, which is a radioactive. But without if we exclude the elements of the radioactive, then cesium is the most reactive one. Next we have transition metals in the center, which are hard, strong and dense metals. And next you can see here we have metalloids. Metalloids include the semiconductors like the silicon, germanium, and they are present here. You can see this one. These are the metalloids. We have silicon, we have germanium. All these are the metalloids which have properties of both the metals and the non-metals, so we sometimes call it as the semiconductors. Next we have non-metals, and non-metals include mostly halogens. The group 7, so group 7 are known as the halogens, and these are the non-metals. Oxygen, sulfur, phosphorus, nitrogen, carbon, all the yellow you can see here, yellow boxes, these are the non-metals. Group 8 are known as noble gases or inert gases, and the elements that are present here are very unreactive. Helium, neon, argon, krypton, xenon, radon, oganesson, all are very unreactive because they have their valence shell that is completely filled with the electrons, so that's why they are unreactive. They do not form the bond with any other element. The elements that are present in the group 1 and group 2 are most reactive elements of our periodic table, and group 8 elements are most unreactive that are present in our periodic table. So you can see here we have transition metals, we have reactive metals, we have unreactive metals, and we have some groups in our periodic table. Group 1 is known as alkali metals, group 2 are known as the alkaline earth metals, group 7 are known as the halogens, and group 8 are known as the noble gases. So the main distinction in our periodic table is between the metals and the non-metals. So we have two different classes of our periodic table in which we classify the elements in our periodic table. First one is the metals and second are the non-metals. So you can see here in our periodic table, the non-metals are grouped in the top right hand region of the periodic table, and one of in our periodic table you can see here mostly these are the non-metals. Mostly these are the non-metals except silicon, germanium, these are the metalloids, and transition metals are also the metals, and the group 1 and the group 2 elements that are present here, these are also the metals. So one of the first uses of the periodic table is now become clear, and we may never see an example of the element we know from the looking at the periodic table that it's a metal. So that is the hafnium. We may also be able to predict some of its properties, like the change from the metallic to the non-metallic properties in the elements across a period. It's not clear cut as suggested by drawing the line between the two regions of the periodic table. So the elements that are present here and that are now referred as the semi-metals or semiconductors, these are known as the metalloids, that have properties of both the metals and the non-metals. Such elements have some properties of metals and others that are more characteristic of the non-metals. So there are 8 elements that are called at the metalloids in our periodic table, which includes the silicon and the germanium. They are neither conductors, they are neither insulators, but they make excellent semiconductors. That's why we call it as the metalloids. And the prime example, as I already told you, that is of silicon that is present here. Next, the elements in our group 1, group 8 of our periodic table, they are from group 1 to group 8, they are known as the main group elements. These vertical groups mostly show clearly how elements within the same group have similar chemical properties and physical properties. Physical properties mostly depend upon the weight or mass, or you can say that the color, like these things, and chemical properties depend upon the chemical bonding which the elements made with the other elements. So as electron has negligible mass, so we can't consider that in that case if there is one or more electron is donated or gained by any element. So if electron is donated, or if we talk about the chemical bonding or the chemical properties that depend upon the chemical bond that some atoms made, so they are just because of that when electrons are gained or when electrons are donated from one atom to the other atom. So that's why we can say that the vertical groups show how the elements within the same group have similar chemical properties, because the group number indicates that the elements that are present there have same outer number of electrons that are present in the valence shell. For example, in the group 1, group 1 means that there is just one outer electron that are present in the elements of this group, like lithium, sodium, potassium. You can see here, if I zoom this one, lithium has total 3 electrons. So 2 electrons are present in the first shell and 1 electron in the second shell. Sodium has 11 electrons, 2 in the first, 8 in the second, and in the third we have just 1 electron. So all the elements of the group 1 have 1 outer electron. Group 2 element have 2 outer electrons. Group 3 element have 3 outer electrons. Group 4 have 4 outer electrons. So this can be applied up to the group number 4. But if we move forward from group 5 to group 7, you have to do 8 minus the group number, means if we 8 minus 5, that means the 3. So these are the non-metals and they mostly gain the electrons. Metals have the property to donate the electrons and non-metals gain the electrons. So what will happen in the group number 5? They gain 3 electrons. When they gain 3 electrons, they have the charge of -3. That means they gain 3 electrons to complete their valence shell. If we talk about the group number 6, 8 minus 5, that means 2. So the charge that are present on the group number 6 is -2 charge, and the total electrons that are present in the valence shell are 6 electrons. 6 electrons are present in the valence shell of the group 6. Group 7 has 7 valence electrons. Group 5 has 5 valence electrons. Group 7 has 7 valence electrons. So this can be applied to all the main group elements that are present there, but there is a exception in case of group number 8. Group number 8 is sometimes also called as the zero group elements because they don't need any electron to complete the valence shell. They have already completed their valence shells and they are known as the zero group elements. Helium has just 2 electrons, so it has just one shell, and that one shell is completely filled. Neon has total 10 electrons, so 2 in the first shell and 8 in the second shell. So that means they don't have any space for more electrons. So the noble gases on the right hand side of the periodic table are least reactive elements in the periodic table, and the group 7, which are known as the halogens, are present on the left hand side of the periodic table, and group 1 or the alkali metals are the most reactive of these. So this is all about the periodic table. Next we will talk about the position of the hydrogen in the periodic table. You can see here hydrogen is present here. It is not placed in the group 1 or neither in the group 2 or in any group. It is placed in the center here. So now we'll discuss about the position of hydrogen. So now the position of hydrogen in the periodic table. Hydrogen is very difficult to place in the periodic table. We have different versions to place it above the group 1 or above the group number 7. More often in the modern periodic tables it is left by itself. As you can see here, hydrogen does not belong to any group. Why it does not belong to any group? Just because of its properties. This is because as the smallest atom of all, its properties are quite distinctive and unique. So just because of its unique properties, it is not placed above any group of our periodic table. It does not fit easily into the trends that we will show in any group, the trends across the groups or trends across the periods. So that's why we place the hydrogen as itself on the periodic table. There are some properties that we will discuss today, or the comparison of the properties of hydrogen with the group 1 elements and also with the group 7 elements. If we talk about the properties of hydrogen, or if we compare the properties of hydrogen with the group 1 elements or with the group 7 elements, so now I will show you here. I have so there is this is a table that shows the comparison of hydrogen with the group 1 elements like the lithium or with the group 7 elements like the fluorine. So hydrogen here, we have a comparison of hydrogen here with the group 1 elements like the lithium and with the group 7 elements like the fluorine. As fluorine is the first element of group number 7, which we call as the halogens. So we have, you can see here, first of all we have the physical states of these elements that are present there. Lithium is present in the form of solid at the room temperature, and hydrogen is in the gaseous form, and fluorine also exists as in the gas state. So next we have the chemical properties, or you can say that whether it is a metal or a non-metal. So lithium, as it is present in the group 1, and group 1 and group 2 are considered as a metal. So lithium is a metal, hydrogen is a non-metal. So there is a difference in this one. Lithium is a metal, hydrogen is a non-metal, fluorine is also a non-metal. So you can see here there is a comparison, or there is a similarity in the non-metal behavior of both the hydrogen and the fluorine. But in case of lithium, lithium is a metal, and it also forms as the diatomic molecules. Hydrogen exists as the H2, fluorine exists as the F2. So you can see here there are some common properties between the hydrogen and the fluorine, but not with the lithium here in the second one. If we talk about the third, hydrogen has just one electron in the outer shell, as hydrogen has atomic number 1, so there is just one electron that is present there. And in case of lithium, lithium also has one electron in the outer shell, but the total electrons that are present in the lithium are 3. as the atomic number of lithium is 3, so lithium has 1 electron in the outer shell. So lithium has total 3 electron, but there is 1 electron in the outer shell. So this is a property similar of hydrogen and also of the lithium. And if we talk about the fluorine, fluorine has total electrons, or you can say that the atomic number of fluorine is 9. So as the atomic number is 9, so the total electrons that are present there, in the first shell we have 2 electrons of fluorine, in the second shell we have 7 electrons that are present there, like this. So 7 electrons are present in the outermost shell. Fluorine just needs 1 more electron. So if we talk about the third one, so this is the third one, lithium and hydrogen have the similar comparison in case of the electrons that are present in the outermost shell. Last properties or last comparison of the hydrogen with the group 1 or the group 7 elements are that hydrogen atom can form either the positive or the negative ion. Mostly hydrogen forms the H positive ion, but H negative also exists. By donating that 1 electron that is present in the hydrogen, hydrogen forms H positive ion, or you can also call it as the proton, right? Because hydrogen has no neutron. And if we talk about if hydrogen forms the H negative ion, that means hydrogen gained 1 electron and now it has the 2 electrons in the outermost shell, or in the first shell you can say. So this is the hydrogen anion that it forms by the gaining of electron to achieve the noble gas arrangement, and this is the H negative ion. In case of lithium, as lithium has just 1 outer electron, so it is difficult for the lithium to gain 7 more electrons. It is more easy for the lithium to lose 1 electron and achieve a noble gas configuration and form the positive ions Li positive. So this is a comparison, or this is a similarity between the hydrogen and lithium, that hydrogen can also form H positive ion and lithium also form the Li positive. But in case of fluorine, atom can gain 1 electron to achieve the noble gas electronic configuration in case of fluorine, because fluorine needs just 1 more electron. So fluorine can form F negative, like this. So this is the comparison, or this is a similar property as compared to the hydrogen anion you can see here. So there is a difference, or there is a comparison between the group 1 and the group 7 elements of the hydrogen. So that's why we can't place the hydrogen in any group, but we place the hydrogen, or in modern tables it is left by itself, as you can see here, just because of its unique and distinctive properties that are present there. Next, we will talk about the organization of the periodic table. So this is the periodic table. Now we'll talk about this, the organization of this one. First of all, first when the periodic table was constructed, we have, or you can say that it was originally provided by increasing atomic masses, not atomic number, atomic masses. But however, later it was found that the atomic number provide a better basis for this one, for putting the elements in order. So atomic number provides a linear or continuous sequence as 1, 2 or 3. If we talk about the atomic mass, there are also not just the whole numbers that are present there. In case of atomic masses, we have also the numbers in the points. So that's why atomic number is the better one. Atomic number provides a linear and also the continuous sequence. So the periodic table is a two-dimensional representation. Two-dimensional, you can see here we have groups and the periods. Periods are the horizontal rows and groups are the vertical rows of our periodic table. So we have the periodic property is the one that show a repeating pattern in the periodic table, and periodic property is a property of the element that show a repeating pattern when plotted against the proton number. How we can directly link the properties of the elements with the position of the periodic table and its electronic configuration. Like the group 1 elements has just 1 outer electron, and Group 2 elements has 2 outer electrons, group 3 has 3, group 4 has 4 outer electrons, group 5 has 5 outer electrons, and so on up to the group number 7, right? So if we talk about the periods show that the number of shells that are present in that specific element. Like if there is any element that is present in the period number 1, like helium, we have helium and hydrogen that is present there, so they have just one shell in which electrons are present there in their structure. If we talk about the period 2, that means there are 2 shells in the structure. Lithium has 3 electrons, so 2 shells are there. Beryllium has 2 shells. Boron, carbon, nitrogen, oxygen, fluorine, neon, all the elements that are present in the period 2 have 2 shells that are present there. So each period in the periodic table represents a filling of an electron shell. There is a clear relationship between the electron arrangement and the position in the periodic table for the main group elements. The main group elements, as I already told you, group 1 to group number 8, except the transition metals. Elements in the same group have same number of electrons in their outer shell. For the main group element, the number of group is the number of electrons that are present in the outer shell, and periods of the periodic table also have numbers. This number shows us how many shells of the electrons the atom has. Like if we talk about the period 6, so the elements that are present there in the period 6 has 6 number of shells, 6 number of electron shells that are present there. Like for example, if I gave you the example magnesium atom, you can see here magnesium is present in the group 2 and in the period 3 of the periodic table. Here magnesium is present here, so magnesium is present in the group 2 and period 3 of periodic table. That means magnesium has 2 electrons in the third shell of its structure. 2 electrons that we can suggest it from the group number. It is present in the group 2, so it has 2 electrons in the third shell, which is the last shell. Magnesium has total 3 shells, first, second and third, so 2 electrons in the third shell of the magnesium atom, and it is present in the group 2 and period 3 of the periodic table. So this is the relationship of the period and the group number with the elements of our periodic table. It is the outer electrons of an atom that are mainly responsible for the chemical properties of an element, because first outer electrons react together or combine together or make a bond with other elements to form the bond. That's why chemical properties depend upon the electrons, and elements in the same group will have similar properties. We have some certain electronic configuration of the elements that are more stable than the others, and the most stable is the noble gases. Noble gases are the most stable one. So this is the link between the group of elements that are present there. Next, we will talk about the group number and the ionic charge. Ionic charge, we have already done with that, but now I will summarize again the group number and the ionic charge. I'm sharing my Now we'll discuss the relationship between the position in the periodic table and electronic configuration. Means that there is a link between the group number and the charge on the ions that atoms form. As we already know about the charges that atoms or the ions that atom forms, we have anions and we have cations. Cations are positively charged and they are formed by donating the electrons, and anions are negatively charged and they are formed by gaining the electrons. So the ions, you can see on my screen, this is the diagram that show the ions formed by the main group elements of the periodic table. In the center we have transition metals. Transition metals have variable valency, means that some can form two or more different ions, like copper. If we talk about the copper, if we talk about manganese, we have iron. Iron has +2 or +3 charge. Copper has +2 and +1 charge. So there is a variable valency in case of transition metals. So we will skip transition metals in this one. We have the relationship between the group number and the ionic charge. you can see that for the metal ions, the positively charged is same as the group number. The metal ions, metals are mostly present on the group 1 and in the group 2 of our periodic table, and metals have free electrons, so they always form the cations or positively charged ions. So metal ions, the positively charged is same as the group number. In the group 1 of the periodic table, all the elements will form the cation with just one positive charge, and in the second one these atoms have lost their outer electrons to form the ion, and in the second group we have, this is the group 2, so they have the charge +2 that is present on it. Next, for the non-metals, the negative charge on the ion, the non-metals of group number 7, of group number 6, so that for these non-metals, the negative charge on the ion is 8 minus the group number. If we want to calculate the charge on the oxygen is present in the group number 6, so 8 minus 6 equals 2. So minus 2 charge is present on the oxygen and all the elements that are present in the group number 6. Just like if we talk about the group number 7, they have minus 1 charge. So these atoms can have gained the electrons to form the negative ion. The atoms of the elements in the middle of the periodic table usually form the covalent rather than the ionic compounds, and covalent compounds are formed by the mutual sharing of the electrons. So this is how you can see here. We are done with the relationship between the group number and the ionic charge. If we talk about the group number 8, you can see here the none is here, so that because noble gases are unreactive, they are inert gases, they don't form the chemical bond with the others because they have already filled completely valence electrons that are present in their valence shell. So that's why they don't form the positive ion or the negative ion, because they are unreactive. Now I will show you the general trends in the periodic table. In the periodic table we'll see the general trends. Like, now we'll talk about the periodic properties in a periodic table. Periods, as we already know about the periods in the periodic table, these are the horizontal rows. So the properties of the elements moving across a period or in a horizontal row in a periodic table, there is a gradual change from metal to the non-metals. You can see here, these are the metals and these are the non-metals. So if we move across a period in a periodic table, there is a gradual change from the metals to the non-metals. On one side we have metal, on the other side we have non-metals. There is an increase in the number of electrons, in a gradual increase in the number of electron in case of period, but not in the groups. In the groups, like in the group number 1, lithium has 3 electrons, sodium has 11, right? And next, if we talk about the third one, we have potassium has 19 electrons. So there is no gradual increase in the number of electrons across a group, but there is a gradual increase in the number of electrons in the periods. Like lithium has 3, beryllium has 4. Next, other element that is present here will be, we have boron. Boron has 5. This is the boron. Carbon has 6, total 6 electrons. Nitrogen has total 7 electrons. Oxygen has total 8 electrons. So there is a gradual increase in the number of electrons across the periods. And the third one, change in the structure, giant ionic to the giant covalent and to the simple molecular structure. Elements that are present on the group number 1 and 2, these are the giant, they form the giant ionic structures, and the non-metals form the giant covalent structures, and the noble gases form the simple molecular structures. They are mostly present as the helium, neon, argon, krypton, like this. They don't form the giant structures. So this is about the periodic properties of the periods. Next, if we talk about the groups, group 1 are called as the alkali metals, group 2 are known as the alkaline earth metals, group 6 are known as chalcogens, group 7 are known as halogens, and group 8 are known as the noble gases or the inert gases. So next, we will discuss about the properties which are present in the groups. As we know that group 1 elements are known as the alkali metals. So now we'll discuss the properties of the group 1 and also the trends that were present in the group 1 elements. So first of all, I will tell you the elements that are present there in the group 1. We have lithium, we have sodium, potassium, rubidium, cesium and francium. These are the elements: lithium, sodium, potassium, rubidium or cesium, and last one is the francium. So these are known as the alkali metals that are present there. Now we'll talk about the properties of these metals that are present there. They are soft solids. These are the soft solids. They can easily cut with the knife. And they are highly reactive as they are stored in the oil to prevent them reacting with the oxygen and water vapor in the air. When we freshly cut them with a knife, all these metals have a light gray or silvery surface which quickly tarnish away and becomes dull when it reacts with the oxygen that is present in the air. So we have some physical properties of the alkali metals. They are good conductors of heat and electricity. They are good conductor of heat and electricity. Why? Because these are the metals, and metals have free electrons, so they can easily conduct the electricity. And they are soft and they have low density. They are solids but they are soft, so just because of its softness their density is low. They are not much dense. When we freshly cut them, they are shiny, but it quickly tarnishes away when it reacts with the oxygen that is present in the air. They have a low melting and boiling points just because of its softness and low density. It is less dense, so just because of its low density they have low boiling and melting points. Next, they burn in the oxygen with the specific flame colors. All the elements that are present in the group 1, they have a specific flame color. They react vigorously with the water and also with the halogen to form the metal halides. When they react vigorously with the water, what will happen? Like sodium. When sodium reacts with the water, the reaction is very it's very explosive or vigorous, and we have oxides that are formed plus hydrogen gases released in case of this one. And when it reacts with the halogen, it forms the metal halides. Like we have KCl, potassium chloride, that is the metal with the halogen that is present there, so we call it as metal halide. And next we have several different trends which are present down the group in this. Down the group, that means from lithium to the francium. So these trends are, now we will discuss the trends here. It's much better. So as we go down the group from top to the bottom, the melting point decreases. Means that lithium has much higher melting point as compared to the francium. So from top to the bottom, as we go down the group, the melting point decreases. MP shows the melting point, so melting point decreases as we go down from top to the bottom. The melting point decreases. And the second is density increases. Means that the elements that are present on the top are less denser as compared to the elements that are present at the lower. As you already know that the physical properties depend upon the mass also. So density, lithium has just 3 electrons in the valence shell or in its structures, 3 electrons and 3 protons, so it is less denser. But as compared to the cesium and francium are much denser. And the reactivity also increases from top to the bottom. Means cesium and francium are more reactive as compared to the lithium that is present on the top of this group, or you can say that the alkali metals. So as we go down, or as we move down, the reactivity increases. So these are the trends metals get softer as we go down, so that's why the density increases, and melting and boiling points decreases down the group. Densities increases as we go down the group, although this trend is also obtained because the value here we can observe the trends in the values for the physical properties, and we can also predict the melting points of this one, like rubidium to be lower than that of the potassium. There must be a gap between them because melting points and boiling points decreases down the group. And chemical reactivity as we go down the group increases. All the group 1 metals react with the cold water to form the hydrogen and the alkaline solution of this metal hydroxide. The production of an alkaline solution can be shown by a few drops of universal indicator to be added to the water. So these observations you can see here are the physical properties or the trends that are present in the group 1 elements. You might predict that francium at the bottom of the group 1 would be the most reactive of all the metals, but it's highly radioactive and it's very rare because it decays with a half-life of just 5 minutes. So that means this amount of francium in a sample is half in just 5 minutes. So it has been estimated that there are only 30 grams of francium existence on the earth at one moment in time. So this is about the chapter number not chapter, this is about the group 1 elements, or which we call it as the alkali metals. In the next group which we will discuss today, the properties and the trends across the group, the second one is the group number 7, the halogens. First, I will tell you about the elements that represent there. In the group number 7, we have fluorine, chlorine, bromine, iodine, and astatine. These are the elements that are present in the group number 7, and we call it as the halogens. These are most reactive non-metals, and we call it as the halogens in our periodic table. In contrast with the group number 1, group 7 reactivity decreases down the group. If we move from top to the bottom, its reactivity decreases, fluorine being the most reactive and astatine is the least reactive of all. Fluorine is dangerously reactive pale yellow gas at the room temperature. It's pale yellow gas at the room temperature. This is the color of the fluorine. And there is if we talk about the other elements of this one, we have chlorine. Chlorine is a pale yellow to green gas. All these are the gases and these are non-metals. And the bromine is a red-brown liquid. In our periodic table, we have at the room temperature, we have two elements that are present in the liquid form. First is a mercury and second one is the bromine. Next we have iodine. Iodine is a gray-black solid. And astatine is also present in the gray-black color. So halogens gain electrons to form the halide ions, which are then reduced, or you can also call it as the redox reactions. So these elements are colored and become darker down the group. You can see here fluorine has a pale yellow color and iodine has the gray-black color. So they get darker as we move down the group. They exist as the diatomic molecules like F2, Cl2, Br2. They exist as mostly as the diatomic ones. They show a gradual change from the gas chlorine to the liquid bromine and to the solid iodine. Iodine is in solid, bromine is in liquid, and fluorine and chlorine are in the gaseous state. They can also form the covalent compounds with the non-metallic elements such as HCl. They react with the hydrogen to form the halides like HCl. HBr, these are the halides like HF, which dissolve in water also to form the acidic solutions. They also react with the metal to produce the ionic metal halides like iron. When react with the chlorine, iron is a metal, so they can react with the metals to form or to produce the ionic metal halides. Iron, when react with the chlorine plus Cl2, after reaction we have iron chloride FeCl3. We will balance out this equation. You have to put the 2 before the iron and 3 before the chlorine and 2 here. So this one is the chlorine gas, can also used as a bleach moist indicator paper. So these are, as we go down, the density increases and the reactivity decreases. So this is the most important one, the trend. The reactivity increases as we go up, or as we go down, the reactivity decreases. If we go down, the reactivity decreases, means fluorine is most reactive. Fluorine is most reactive and iodine or astatine are the least reactive one. Second, density also decreases, means fluorine is less denser and astatine is more denser. Iodine and astatine are present in a solid form, so they are more denser. So density increases from top to the bottom. From top to the bottom, density increases but reactivity decreases. So these are the specific trends of the halogens that are present there. They are poisonous and they have a similar strong smell. They are non-metals, and as I already told you about, they can form the hydrogen halides. Each have a series of compounds like chlorides, bromides, iodides, and together you can call it as the halides. The halogens can react directly with the metals to form the metal halides and also the salts. So these are the trends that are present there, or the physical properties of the halogens that they show. We have also the reactivity of the, or you can say that the halogen displacement reactions. Like we have hydrogen. Hydrogen will burn in the chlorine to form the hydrogen chloride, like H2, hydrogen gas with the chlorine gas to form HCl. Hydrogen dissolves in the water to give the acidic solution, like chlorine. When dissolved in the water, it forms hydrochloric acid, plus we have hypochlorous acid, that is HClO, hypochlorous acid. So chlorine water act as an oxidizing agent, or hypochloric acid can also give up its oxygen to the other substances. This hypochloric acid, it also act as a bleach, because some colored substances lose their color when they are oxidized. So this reaction is used as a chemical test for the chlorine gas also. And halogens become steadily less reactive as we go down. We have also some halogen displacement reactions that show the lower part to demonstrate also the order of reactivity of these three major halogens. Like chlorine is more reactive than bromine, so it replaces bromine and potassium chloride is formed. Like as chlorine is more reactive, fluorine is highly reactive. Second we have chlorine. Third we have bromine. So when chlorine react with the potassium bromide, as bromine is less reactive, so chlorine can replace the bromine, because chlorine is more reactive, bromine is less reactive. So we have the displacement reactions and KCl is produced, plus we have bromine gas that will be formed here. Like this. We will balance out this equation. There should be 2 KBr and 2 KCl here. So chlorine can also replace the iodine from the potassium iodide, because chlorine is much more reactive as compared to the other halogens. Next we will talk about the group 8 elements, or the noble gases. So now the next group which is the group 8 of the noble gases. All the noble gases are present on the Earth atmosphere. Together they make up about 1% of the total, though argon is the most common one. These gases are particularly unreactive, and that's why they are referred to as the inert gases. They are also referred as unreactive because they are unreactive, and they are also known as the noble gases or unreactive. We have helium, neon, argon, krypton, radon, and xenon. All these are the noble gases. The use of the noble gases depend upon their reactivity. Helium is used in the airships and balloons because it is light and unreactive. Argon is used to fill the incandescent light bulbs because it will not react with the filament even at the high temperatures. And the best known use of the noble gases is perhaps its use in the neon lights, the brightly colored advertising light color when an electric discharge takes place in a tube containing the small amount of a noble gas. So different gases give the different colors. Atoms of the noble gases do not combine with each other to form the molecules or any other form of a structure because they are unreactive. Their melting and boiling points are extremely low. Why their melting and boiling points are low? Because they are in the gaseous state. So that's why the melting and boiling points are low, extremely low, because of its physical state, that is the gas. Helium has the lowest melting point of any element and cannot be solidified by cooling alone. Pressure is also needed for this one. So we have some trends of the properties. The electronic configuration of the atoms are very stable. So they are stable. The first property is because they have completely filled valence shells. That means that they do not react readily with the other atoms. In many situations where atoms of other elements bond or react chemically, they are trying to achieve energetically stable arrangement of the electrons that are found in the noble gases. So the elements of the group number 8 lie between the two most reactive groups of the elements, group 1 and group number 7. Group 1 is the most reactive in metals and group number 7 is most reactive in non-metal. So indeed, it is their closeness to this group with a stable electron arrangement that makes the alkali metals and the halogen so reactive. So they can fairly achieve a noble gas electronic structure in that. Now we'll discuss the trends. In this also we have, they are colorless gases, they are monatomic gases, mostly are colorless, and they are monatomic. Monatomic because of its unreactive nature. Now we'll discuss the trends across a period. The elements of the vertical groups at either side of the periodic table show similar properties within the groups. However, following a period across the periodic table highlights the trends from the metallic to the non-metallic properties within the periodic table. In a specific period, we have elements that are present on the left side of the period, you can say, are the metals, and the present that are present on the other side, those are the non-metals across a same period. So this change from the metal to the non-metal can be explored by looking more closely across each period. The first period of the periodic table just contained the two elements, hydrogen and the helium, both of which are distinctive and unique in different ways. And the final period in the periodic table is now recently complete with the discovery of the elements such as the oganesson. So each of the 5 remaining periods of the elements start with the reactive alkali metal and finishes with the unreactive non-metallic noble gas. In the period 3, for example, sodium to the argon, there appears to be a gradual change in the physical properties. As you can see here, this one, the period 3rd, that start from the sodium and ends at the argon, there appear to be a gradual change in the physical properties. The change in the properties seem to center around the silicon, and elements before this behave as the metal and those after the silicon behave as the non-metals, you can see here. So now we'll discuss the change in the properties of the elements in the period 3 and the group 4 of the periodic table. Period 3 and group 4. So this one is the diagram for this one. You can see here the blue are the metals, the orange are the metalloids, and the yellow are the non-metals. So the atomic size decreasing from bottom to the top, and the atomic size decreasing from left to the right. How is it possible? You can see here the change in the properties. If we look at the group 4, as we go down, the change is from a non-metal to a metal. The metalloids, silicon and germanium are in the center of this group, and the metalloids, silicon and germanium are center of the group. The different structure of the elements in the period 2 and period 3 are reflected in their boiling points and also in the melting points. We have, if we talk about the as we move across a period, there are also differences in some chemical properties linked to the metal to the non-metal transition. Metal oxides like magnesium oxide are usually basic. If magnesium forms an oxide MgO, that is basic in nature, and while those of the non-metals like sulfur dioxide, when sulfur forms the oxide SO2, which one is acidic? So which one is acidic? And magnesium forms the basic one. So you can see here there is a gradual change in this. Therefore this change from basic oxide to the acidic oxide as we move across a period. In the third period, magnesium forms the basic oxide, which is a metal, and sulfur is a non-metal, which forms the acidic oxide. The change from the metal to the non-metal across a period show itself in changes in bonding type from metallic bonding to the covalent bonding. Metallic bonding is present in the metals like of magnesium and sodium, and covalent bonding is present in the in the non-metals. And to be more precise, in the period 2 and period 3, there is a shift from metallic lattice to the giant covalent structure and then to the simple molecular structure. Giant metallic structure is formed by the metals that are present here, sodium, magnesium, and giant covalent structure is formed by the elements that are present there like sulfur, phosphorus, carbon. All these form the giant covalent structure, and the simple molecular structure is by the noble gases as we move across a period. So this is the trends that represent across a periods. So next we will talk about the last elements of our periodic table, which are the transition metals or transition elements. Sometimes we call it as transition metals, and you can also call it as the transition metals. They are present in the center of our periodic table, and they have variable valency, they have variable oxidation states. That's why we separate them as a separate group. As we look at the period 4 in the periodic table, you can see there is a whole block of elements. Like here, this whole block of elements, the one which I circled here, are the transition metals or the transition elements. This block of elements fall outside the main group of the elements that we talked about so far. The main group includes the group 1 to the group 8, but these are exceptions because they are best considered as the vertical groups of the elements, but as a row or a block. They are referred to as transition metals or the transition elements, and the most useful metallic elements available to us. They are much less reactive than the metals in the group 1 and the group 2, but many are excellent corrosion resistant like chromium. So we will talk about the properties of these. Chromium, that is present there. Chromium is an excellent metallic element and corrosion resistance. Chromium has the properties of the corrosion resistance also, like aluminium. Aluminium also resists the corrosion. And the very high melting point of tungsten led us to use in the filaments of the light bulbs. So they have some distinctive properties due to which we separate them as a transition metal. Many of the compounds of the transition metals are colored, and when this is dissolved, they give colored solutions. Now we'll talk about the journal features or the journal properties. Mostly the journal features properties include they are hard and strong, so we can use it at various stages. they have high density. As they are hard and strong, so they are much denser as compared to the other elements of our periodic table. They have high melting and boiling points. High melting and boiling points. Why high melting and boiling points? Because they are hard, they are strong, and they have more density. They are more denser, so that's why they have high melting and boiling points. Many of the compounds are colored, and they often have more than one valency or variable oxidation state, like iron. Iron has the oxidation state of +2 and also +3. So just like iron, we have copper. Copper has +2 and +1. So they often show more than one valency. Most of the elements form the amphoteric oxides also. We have read about the amphoteric oxides in the chapter 11 of the acid bases, so you can check the amphoteric oxides from that chapter. So aluminium also forms the amphoteric oxide like Al2O3, and chromium oxide Cr2O3 is also the amphoteric oxide. So this is about the transition metals that are present there, and they have high densities, they have high melting and boiling point, except mercury. There is also one acceptance, that is mercury, which is a liquid at the room temperature and the pressure. So mercury has much lower melting point as compared to the other transition elements. They form the colored compounds. They often act as a catalyst as elements in the compounds, as we have read about in the Haber process and also in the Kontrich process. Iron is used as a catalyst, vanadium oxide is used as a catalyst. Both of these are the transition metals. They are harder and stronger, and they have higher density than the metals in the group 1 and in the group 2. So transition metals can have the ions with a multiple different oxidation numbers. So I think this is all about related to this chapter, and I will summarize all this in just 1 or 2 minutes. First of all, we read about the organization or classifying the elements in the periodic table based upon their increasing proton number. Second, we discuss about the electronic configuration of the elements that determines the group in which an element is present. The ionic charge of an element relates to the group number. Third, next we discuss about the chemical properties and the physical properties of the group 1 elements. Next, group 7 and also the group 8, and last we talk about the transition metals. Transition elements or transition metals have certain common key characteristics. So transition metal atoms can able to form the ions with a variable oxidation state, and mostly they are the colored compounds, or you can say that they form the colored compounds. And noble gases are unreactive monatomic gases, and they have 8 electrons in the valence shell except the helium. Helium has 2 electrons in the valence shell. So this is all about the chapter, which is the periodic table, and we have completed all the contents which are included in this chapter. Hope you understand all this. If you have any question or any query, you can ask in the comment box. And if you like this video, please subscribe our channel. We'll meet in the next one.